One of the most important results that calculus gives us is the idea of the integral. The integral is one of the first concepts studied when calculus was first being discovered, because the integral represents the way to sum up individual pieces. And while we're not going to get there right now, that's kind of the idea behind it. It's trying to represent amount of total change. So if we have that big F is an antiderivative of little f, then we can perform what's known as, or apply what's known as an indefinite integral. The indefinite integral of f, so little f here, with respect to x, is given by this notation. So it's this integral symbol, it kind of looks like what you might see on like a violin or something, and f of x dx. So it's the integral of f of x dx. Now, what's helpful is that the indefinite integral of f is exactly equal to the general antiderivative of f. So the indefinite integral of little f is equal to big F plus c. Now, there's a lot about where this comes from, and we'll get there. But the shorthand version is that if we have that differential equation dy dx equals little f of x, if we treat dy dx like a fraction, which it isn't, but if we just treat it like a fraction, you have that dy equals this f of x times dx like we have here. And if that differential piece, right, it's that little differential piece of y is there, and we sum up all those little differential pieces, we put them all together, this integral symbol here is the idea of a sum. So we're putting all of those pieces together, and when we do, what we arrive at is the big function. Now, there's a lot that I'm hand waving and not discussing here, but that's the general idea. So anyway, what we can do is evaluate these integrals, and the process is exactly the same as finding an antiderivative. It's just a different notation. So to do that, the first thing we want to do is we want to rewrite this in a convenient notation. The fourth root of x is the same thing as x to the 1/4. So now that we have something in terms of x to a power, we can apply the power rule. Right? We add 1 to the power and divide by that new power. Sorry, that's not 1/4. That new power is 5/4. And that's 5/4. So this gets us that answer. Right? We take this, we flip the reciprocal, or get the reciprocal, so we get 4/5. 1/4 plus 1 is 5/4. So that's the idea for that particular problem. Now, for the next one, it's going to be the same idea. We want to rewrite this. Now that it's been rewritten, we want to add 1 to the power. And we want to divide by the new power. That's a perfectly fine answer. However, you may prefer to write it as something like, or even, that's probably a little bit overkill, but that is a way to write that it is a perfectly acceptable answer.